So as Lee said, I'm talking about concurrent mode or React Suspense. The two terms are, I don't know if they're interchangeable at this point, but there's certainly still a lot of work being done on the APIs. And so I don't think anything is set in stone right now. I decided to title this talk React Suspense because I'm mostly talking about how suspense is useful in the React sphere right now, and how we can implement concurrent mode. So about me, I'll go over this pretty quickly here. So I'm a JavaScript developer. I'm currently employed at Redspace. I'm a husband, I'm a father, and a dog owner. And I'm working full time in React right now, which has been pretty fantastic. I've been doing that for, I guess, a few years now, and it's been a pretty great ride so far. So what are we going to talk about? The first thing I kind of want to bring up today is talking about React Suspense and getting people familiar with the API, because it actually has existed in React for some time now. And so I'm sure some people have actually already implemented it, but we're going to go a little bit deeper into how we can start using suspense boundaries in tandem with concurrent React, and do some promise-based rendering, which is some pretty hip stuff for those who haven't seen it. It's pretty fun. And then finally, we'll get into a bit of how the config is set up for suspense, and how to really make what the React team likes to call intentional loading states. So I'm going to go over a few things that I'm assuming people are aware of, or maybe things that I'd like to clarify. First of all, I'm hoping that people are at least familiar with the basics of React as well as hooks. If you're not, I do have some slides, which I've linked here, to a previous talk I've done on just kind of introducing people to React and the basic API. I'm hoping that people understand promises in JavaScript. So the idea behind a promise is that it is, well, like everything in JavaScript, it's an object, but it represents the eventual completion or failure of an asynchronous operation and its resulting value. So these are pretty critical to the talk I'm going to be doing today, and how we can utilize promises to really bring the asynchronous operations to like the core level of how we're writing our React. So I'm also going to talk about boundaries a bit. I'm going to use the term, it's not really that complicated. The idea is that just anything that you bound within a JSX tag, that thing that bounds it is what I'm going to call the boundary. So when I write a suspense tag and put anything inside it, that suspense tag will act as the suspense boundary. I might also use an error boundary here and there. Pretty good things to throw in your app if you're not doing it already. Catch any errors and prevent some really ugly UI from appearing on your screen. And then I'm also hoping people understand the fetch API. So this is something that, again, it's comes right out of the box with JavaScript. You don't need to be a React developer to know about this. I'm sure anyone who's been writing JavaScript knows fetch, has worked with it quite a bit. And it's just an interface for fetching resources, either locally or over the network. And I'm going to be using it here. I'm going to get some data from the Star Wars GraphQL API. Nothing complicated, but it'll be fun. So getting into React Suspense. So this was actually introduced in 16.6. So as a reference point, 16.8 came out last February, and that's the one that had hooks. So React Suspense has actually been around for a little while now. And so what it does is it allows you to wait, and I've got that in quotes there, it allows you to wait for some code to load, and you can specify a loading state that you can fall back to while you're waiting. So the suspense boundary takes a prop, that is your fallback, and anything inside it is what it's waiting for. And so what this does is it opens up a whole new way of writing our UI, where we can go over this render as you fetch paradigm. And I'll go into that a little bit more in comparison to some other things that we might be more used to. And another thing that's really important in bringing up kind of right off the bat is that this is still in an experimental release. It's actually not, the Suspense API has been out for a while, but concurrent features and a lot of the APIs I'm going to be using they're still in experimental release. And so a lot of the APIs are likely to change. So the fundamentals, the concepts, those are going to stay. That's what's going to be useful out of this talk. The exact API and how I implement it likely will be modified somewhat by the time we ever start using this stuff in production. So don't need to get too married to the API. So I've got some images here which really clarify the difference between some paradigms about how we're used to rendering our React UIs. So the render then fetch method this is pretty common. This is what I've been doing in most of my code for a while now. And the idea is that you render some component, and then within that component, you might have some lifecycle method, like a component didn't mount, or you're using hooks and you've got the use effect, much like Ali did. And the idea is that you can see here in the waterfall from our network tab that first you're loading in this component. And once that component finishes loading, you then make a fetch to some API. And after that fetch completes, you're going to start bringing in the data and maybe load an image or some other stuff. So this is the kind of waterfall. You render, then you fetch, then you re-render. And that's what we're kind of used to doing as React developers. But what render while as you fetch provides is the ability to kind of flip that on its head. And you can make the fetch request at the same time that you load up your component. So you can see here the component's loading as the fetch request is loading. And so you've got some sort of API in all of this that's handling the loading state. And once that completes, it's all ready to go at the same time as your component has loaded. So it's a pretty fantastic way of writing our apps. It's going to make things a lot more performant. It's going to make things a lot more user-friendly. And I think it's really going to change the way we start writing our code. It's a pretty exciting new shift. So I'm going to talk a bit about suspense boundaries. And again, it's not that complicated, but it's important to go over the difference. And so what I've got some code here on the screen, and this is something you can be doing right now. It's something that many of you might already be doing. Lazy loading components is a pretty popular thing to be doing. And so the idea here is that I've got some component, a profile page, and I'm importing it, but I'm wrapping that in this react.lazy. And so what this does is it passes me back a promise. And so when I wrap this profile page inside a suspense boundary, just that suspense component, I'm just going to call it a suspense boundary. It seems to be the terms that people are using. While that promise is unresolved, we get this fallback of a spinner. And then once it finally resolves, the fallback disappears and we're shown the profile page. And so this API is something that you can be using right now in your apps, and I recommend playing around with it. It's a lot of fun, and it can actually really improve the performance of your apps because you can start code splitting and doing all kinds of really great stuff. So I'm hoping that some of you are familiar with this, some of you aren't, but the point is this is what a suspense boundary is. It allows you to provide a fallback while the children are loading asynchronously, and it makes it simpler to build intentional loading sequences. So next we're going to get a bit into promise-based rendering. And it's, once you kind of wrap your head around it, it's not that complicated. It almost makes a lot more sense than not doing it. So your child component, that would be in our previous slide, that would be our profile page here inside the suspense boundary. Your child component utilizes promises and errors to determine its loading state. So if that child component throws a promise, and yes, we're actually going to be throwing promises from our return method of our functional components, it will just render the fallback that's in that suspense boundary. If we throw an error, we're going to, well, it's just going to bubble up until you hit the nearest error boundary. So ideally, you've got your app bound in some kind of error boundary so that you don't have big UI blowups or a white screen. But the idea here is that when we're fetching, over a network, you're inevitably in production going to get some sort of network request somewhere. Some user someday is going to be loading their app and their internet connection is going to go out and their fetch request is going to fail. Having an error boundary allows you to handle that gracefully and decide what the appropriate response is. Maybe you can ask the user to try again, or maybe you can just say that there was an error. And then once the promise resolves normally and you just get a result, all you do is you re-render your component as you're used to doing in React. So this is kind of a bit closer to an example of what a promise-based render is going to look like. So we've got some profile page here, and inside it we've got a suspense boundary and an error boundary. Again, this error boundary is some component we would define somewhere, it just handles errors. There's some really good examples on the React docs, and I've got one in the code I'm going to show you here in a bit. And so we've got this profile details component. And so I kind of skipped over this resource up at the top, and we'll come back to that. But the profile details component is defined right here. And so all it is it's going to return an H1 with our user's name in it. But before it does that, it does this. It says, hey, I need this constant. It's going to be called user, and I'm going to get it from my resource. And this is kind of the API that people are working with. And the implementation of this might change, as I've said before, but the idea is you've got some resource and you read it. And that action of reading is going to determine whether or not this fetch is throwing a promise, if it's throwing an error because the fetch request failed, or if it's returning a value because the fetch request has resolved. And so here, if we call this and the promise hasn't resolved yet, it'll throw a promise and we'll get our fallback. If we read this and it's errored, we'll get our error boundary. And if we read this and it's resolved, we'll get our profile details page. So this is what I mean by promise-based rendering. And so this is what's new and fancy about this. And I've got a cool example to really show you how nice it can be. So before I get into that, I'll talk a little bit about the concurrent API. So one thing that's really neat about concurrent mode is that they've really modified how React is rendering things. And so it used to be that you couldn't interrupt something while it was rendering, but concurrent and wrapping things in a suspense boundary actually allows you to prioritize and interrupt work and interrupt rendering. So you can avoid things that we're very used to dealing with, like like a screen flickering and complex debounce or throttles that you might have in a if you're updating some search bar, you might have to debounce your updates so that you don't start re-rendering the page until you've stopped typing for a few seconds. These are something that I think a lot of people in a lot of frameworks have encountered. Anyone who's familiar with writing web apps has certainly seen screen flicker and needed to use debouncing or throttling to solve those problems. And so interrupting renders is a really new way of handling that problem. And so I've got this thing, the FOOC, the flicker of unstyled or unintentional content. This is a term I like. What do they have it on Wikipedia? Flash of unstyled content is what they call it. So one thing that they've done at React is, I mean, they're hosted at Facebook, and so they have a lot of resources available to them. And one thing they've really done is taken advantage of the research that Facebook has done into user reaction to websites. And they've really implemented that into a lot of the new stuff that they're doing with concurrent mode. And so research has shown that displaying too many intermediate loading states actually makes the loading time seem longer to the user, even if it's the same amount of time. So only showing loading states when you intend can really make a big difference in the user experience. Even if the amount of time you've waited is the same, it feels shorter. And so Suspense handles a lot of this out of the box, which is a pretty cool feature to have. And then so this other thing we're going to make use of is the use transition hook. So this is a new hook that's going to be released. I'm hoping the API on this one stays the same. I really like it. And so the idea is that you can avoid undesirable loading states, like avoid these like too many loading states or flash of unstyled contents by waiting for content to load before transitioning to the next screen. So it's demo time. We're gonna get into a demo. And so I've got a code sandbox here. I thought about making a GitHub, but I figured the code sandbox is just as easy to share, and people can kind of hop in there and bop around. So a few little things up front. You can see my dependencies. I've got React. I'm using the experimental release of React and the React DOM. So this isn't what you get if you just did, npx create React app. You'd have to go in and modify which versions you're using to start using these concurrent mode features. And another thing you need to do, so this is the way we used to do it. We find our root element and we do the React DOM.render, and we just render our app in the root element. And you can see I've got two React apps there. One of them is not using concurrent and the other one is. But and oops, hello, there we go. Get rid of you. There we go. So this is old news. What we want is the new news. So we're using this React DOM.createRoot. And so the create root is actually an asynchronous function. And so we create root with our root element, and then we render. And we render our React app inside there. So those are really that's the entirety of just enabling concurrent mode right there. Updating to the experimental release and using this new API, create root.render. So then when we're inside our app, we can just start making use of the concurrent mode features. And so the fundamentals of what I've got here is actually pretty straightforward. I mean, I've got a div, I've got an h1 in here. I've got a little search component. This shouldn't be a big jump for people. It's a pretty straightforward search component. I'm using state inside it just to handle what the state is inside this. So this is a little controlled input. On submit, I just do this. I pass in a on submit function and I pass it back. It's very straightforward. But then I've got down here, I've got my React.suspense boundary. And so I've got a fallback function here, or a fallback component. And what I do here is I've actually got a character resource. And so I initialize this as just being null. And I talked before in my slides about a resource, and we talked about reading the resource to do promised-based rendering. So what a resource is right now is all I do is I've used this create resource function. This API is, again, it might change, but this is just something that we can do. And all we do is we pass in an asynchronous function to this, and we just let the promise be the asynchronous function and a then. And so while this asynchronous function is running, our status is going to be pending. So down here at the bottom, when we do our read, it says, hey, if our status is pending, throw a promise. If our status is an error, throw the result, which would be right here, and it would be the error that we got. And if our status is successful, right here, once we get our result from our promise, we just pass back the result. And we return. See, we throw a promise, we throw an error, and we return the result. And I've got this down here, throw an error. This should be impossible. Yeah, that should never happen. In fact, I could probably remove that line. But anyways, coming back here. So after we submit our form with our new character name, we're going to set this character resource here. We're going to set our state, our character resource state, with this create resource method, and we're passing into it our asynchronous function, which is a fetch character. And so this is just using the fetch API. I'm going to hit the Star Wars GraphQL. It's right here. It's pretty straightforward. I build up a little GraphQL query. I hit the Star Wars API and return the value. So what we're doing is we're creating a resource with this asynchronous fetch function and setting it to this character resource value in our state. And we pass that down to our character component. So we wrap our character component in an error boundary and we pass it down. So what this does is that now I can come over here and I can search any Star Wars character. And when I submit this, it's going to turn into a promise. And that promise is going to make us get our fallback. And you're going to see that. We've got our flickering fallback there. And once it resolves, we pass the data into our character component, which just spits that data out, the character's name and everything else. And so this is a pretty thorough loading state and error state and everything else that we want right out of the box. And all I had to do was set what my fallback was and build up this idea that instead of handling my is loading or is error, what I'm really doing now is I'm letting the fetch API handle that. And my loading is determined on whether or not the promise has resolved yet. So we're really kind of linking into the core concepts of JavaScript rather than trying to rebuild all of that in our own logic. So you will notice that when I do this, there is a moment kind of before it goes to that fallback. And so this comes back to the point that Facebook had said they're having too many loading states can be make the user feel a little bit like it's taken longer than it really did. And so the suspense boundary itself actually has a default amount of time that it will wait before it renders the fallback. Rather than flickering, it will wait at least half a second before it uses that fallback. So this is where we want to use our start transition or our use transition hook. So I'm going to uncomment a bit of code here. I've got a little suspense config variable. All I'm doing right now is I'm just saying this is how long I want to wait before I display the fallback content. And I'm going to bring in this use transition hook. So again, it's react.useTransition. I'm just passing in my config that I just declared, and it returns to me a function, start transition. And so here is when I would let React know, hey, I'm starting my transition for something. And then here is going to be the is pending. And so this is pending variable lets me know, has that transition finished loading yet? So I'm going to make use of that. So here we had the set character resource, and we just set the character resource state with our create resource promise. And so here, all I'm going to do is I'm going to wrap that in a start transition. So now React is going to know that I've got this character resource being declared inside this transition. And so it's going to provide me a few other APIs. Which is pretty neat. And so if I do this right now, it won't have made a difference because I won't have used any of that state in my UI. But if I come back down here and I say, okay, my character info now is also going to have a little, I'm going to make use of that is pending variable. So if this thing is pending, I'm going to pass a pending class name to it. And I've set this already up in my CSS here. I say, if the character info div is also pending, set its opacity to 0.5. So what we're going to see here is we've got sort of a multiple UI states where when I click this, well, the first time it just jumps straight into the fallback because there wasn't anything already there. But if I do this again and I say, hey, I want Luke Skywalker this time, or you know what, let's do someone cooler. Let's do Boba Fett. This time I want Boba Fett. When I click this, first it becomes slightly opaque, then it goes to the fallback, and then it loads. And all of this is coming right out of the box with React Concurrent Mode. So I hope that is a really good introduction and kind of whets your appetite for what this is capable of, because it's capable of so much more. There's also suspense lists where you can have multiple suspended components and determine the order at which they load. You can prioritize which parts of the screen are going to order, in which order they load in. So even though we're rendering as we fetch, we can determine if things appear before other things and what order they come in. It's a fantastic API, and it's going to really change the way that we write our apps. So that is basically everything I had. I'm really hoping that that people have some questions for me. So I'll jump right to the questions box there. Maybe not. Hello? Maybe Lee, you want to?
Hey, man. Great presentation. I don't think there's any questions, but we can always continue the conversation afterwards. And Lauchie's on LinkedIn and stuff like that. So if anybody does have any questions, they can always follow up with him. Yeah, really great stuff, man. I'm excited for all the suspense stuff. It's wicked, and it's good to see. I think we're going to see a lot more we're going to see a lot more like libraries and stuff starting to incorporate a lot of this, like we did with hooks. We've seen, like Redux and everything else starting going to hooks. And I think we're going to see that with Suspense more too, and kind of having all these libraries add Suspense like features to them, which is I think is going to be fantastic.
Yeah, absolutely. I think that's a really good point.